Welcome to Mentor, a Siemens business, and we're here at Electronica. I'm joined by John McMillan here on my right and Mark Lane on my left. John represents the schematic and schematic verification side of the design business, and Mark here is more involved in the board layout. So welcome, gentlemen. If I can start with you, John, tell us a little bit about some of the key criteria that goes into the schematic systems that you're offering.
Yeah, I think one of the things companies are striving for now is to be best in class, and best in class means to get first pass design success is, I think, the desire of most companies, especially when time to market is very critical. Mm-hmm. So what we do is we're trying to put in a lot of the checks and validation features that you would normally maybe not get performed till the end of a cycle and bring them all in. It's more of this shift left thing, of bringing in analysis, verification, and do it along the way and not waiting until the end to find out things are wrong.
So this is really coming into the real design for manufacture, bringing that information back to the designer.
DFM, co-design, collaboration, and even on the schematic side, analysis and verification, pre-layout.
Okay, great. So you then put that into some sort of a digital twin that
we do.
You would emulate?
So first, our validation is schematic. It's we have a very extensive tool that does over 150 checks that enables you to check the schematics. Within that, we also have a substantial model library to ensure that connectivity is correct. So before you start out in the layout piece, we've already run a complete set of simulations that aren't typically available early on in the design, so that you know that when you go into layout, you're not going to be going back and forth, correcting a bunch of issues or finding them after the fact. Right. So, that's the most, that's a big key part of our.
Okay. So then we take that schematic, we take it forward into layout, and what sort of checks and balances go in there?
Well, obviously you've got the performance of the product. The product needs to perform to its design specification, but also it needs to be built. It needs to go through manufacturing, the typical processes. You talked about the digital twin of the product, but there's also the digital twin of the process and the digital twin of production. Your ability to be able to do that. And so those are the sort of things that you can't leave till late in the design process. We want to be able to left shift those back into the process of design. So instead of doing a lot of analysis at the end, where cost of change becomes nigh and impossible to affect, we want to be able to move those things, and as the design evolves, concurrently run that analysis. From the component placement, from the initial routing to the final routing, and so those tools are running that analysis all the way through the design process. And so we're taking that technology and we're making it available within the design tool and putting it on the desktop of the engineers to be able to leverage that all the way through the design process. And so when they get to the end, you've got something that performs as its product specification, but also can be assembled, it can be tested, it can be inspected as well, so that it's successful coming out of the design process into manufacturing as well.
Right. So, is the design, the digital twin which you use for design for production, is that reducing the number of turns that manufacturers are having to physically make before it goes into production?
Yeah, very much so. I mean, certain design spins can actually be to support manufacturing. So you've got the one there that might be focused on the manufacturability of the product, or another one that's the testability of the product. Yeah. We can't afford to have these extra design spins. Some of these products might be on the market for 3 months, and so if you're taking a few weeks to do a typical design spin, typically a couple of weeks, that's a lot of time to market that you're losing. And so we need to compress that time. It can be challenging. The easiest way is to remove those extra design spins out of the design process. So instead of 3 or 4 spins, we're down at 1 or maybe 2, and then we can achieve those time to markets.
And you're actually building in testability into that.
Yeah, very much so. Testability is another area that traditionally is done very much after the fact, and it's just not feasible to achieve that change there in the same way for DFM. It applies to DFT. And so we need to be able to understand that, and that's something that we can go back to the schematic, start analyzing the schematic, taking it into layout, implementing the test strategy within the layout, obviously. That can also mean inspection issues as well. whether companies are AOI or using X-ray inspection, all of those can be affected by the design. Right. So the more we can move that analysis into the design process, the faster we're going to be able to launch those products into manufacturing and out to the customers.
Right. Okay. So the big thing that's on everybody's lips here at the show this week, of course, is the problems we're having with device and component availability. It's causing havoc in the manufacturing systems, and in some cases they're not able to get devices, and they're literally being asked to redesign the board. How do things like that affect designers that are working with your product?
Well, I mean, it's important to be connected to your systems where you're getting your component suppliers are, not only availability and pricing. So being connected in those ways will ensure that you don't have those downstream problems.
Right. Okay.
Yeah.
And does you also say on the Vala side of your business, you have a big components library. Does that help to draw on that information to sort of help with any turns or redesigns?
Very much so. So the analysis you're referring to, a lot at the front end is the performance of the product, and is that component change conducive to the design? Is it aligned with it? But there's another element which is the physical side. If I switch parts, it may be electrically equivalent, but physically it's different, and maybe that could affect the manufacturing yield that we see in production because it's a little bit bigger, it's a little bit smaller. The good production yield that I was seeing may be affected by that physical change in the component. So although it's electrically equivalent and it does the job per the design that they verified as part of the design process, when I go to physically make that change, that part is slightly different, and that can affect significantly on the yields as well. So yes, we also need to be aware of that one and make sure that when we pick that alternate part will still work physically on the design and deliver on the quality that we were expecting before. So it's a very complex issue. It's not just a matter of simply picking another part. Yes, we need to verify it that it's performing in the way that the design works, but also that it's still achievable from a manufacturing perspective as well.
Well, unfortunately, it's a big issue in the industry, but it's great to see how the Siemens Mentor partnership is really closing that complete DFM loop and getting the information back to the designer. So, gentlemen, I want to thank you both very much for joining us today.